hi everybody, and welcome to another episode of YFTT, Yugabyte Friday Tech Talks. This week's topic, or this episode's topic, is our Performance Advisor, something that keeps monitoring workloads and suggests how you can, transparently improve it, et cetera, instead of, like Sushant was saying, having to do a lot of work and trying to figure out what are the set of things you need to look at and remember all of them, and and so on and so forth. So anyway, I'll let Sushant go deeper, but once again, if you guys feel free to say hi to us, we'd love to hear from you guys. We have some regulars. If you guys are around, say hi. And if you have questions, drop it in our LinkedIn, comment box right there, and we'll answer. We'll get to it. And also, if you have questions and want to, stay in touch or do something beyond, join our Slack channel, yugabyte.com/Slack. Okay, with that, I think let's get started. Sushant, I'll let you introduce yourself, but Sushant comes with a wealth of background in the Postgres in the Postgres database in specific, right? So, but maybe Sushant, you can introduce yourself. And Pranshul says hi. Hi, Pranshul.
Yeah, thank you, Karthik. Hey, my name is Sushant Mishra. I'm a part of the core database team at YugabyteDB. I came on board around a year ago. Before that, I spent around 6 years in AWS Relational Database Services Group. And that's where my love affair with databases started. I was part of the founding member of the Aurora Postgres team at AWS, and later I moved to the open source Postgres, where I spent a couple of years as well. So that is my brief background. And hi to everybody. I'm looking forward to the suggestions and the questions from you, and hopefully we will be able to take up good ideas today out of it as well. With that, I'll get started on today's presentation and the demo. So today we are talking about the YugabyteDB Performance Advisor. So
maybe kick us off with why Performance Advisor, right?
Yeah, so, exactly. So one of the hardest thing is like it's a little bit harder to kind of operationally manage a distributed database cluster. And why do we say this, right? So consider the case of a single node monolithic database. And if we need to debug a performance issue in that, then the general cycle goes as we monitor the CPU, memory, network, IO utilization of that specific node and the system. We monitor all kinds of database metrics and events, wait events, logs, whatever the database provides. And we correlate all of this information. And if one is lucky, then they may just end up spending like, a couple of hours solving this, or sometimes it even goes on for much longer. Now let's move to the distributed system. It adds another dimension to the to debugging the issues, in the sense that a query executing on a node can be interacting with multiple nodes in the cluster. So now we have to really analyze the system as a whole, not only one individual node, but like take information of each individual node and correlate them together to figure out where the problem is. And which makes the problem in a much harder than even analyzing a single node system. So single node system was hard, and then we added more dimension on it. And this is where the idea for Performance Advisor was born. That, hey, can we really go and auto-detect based on the various metrics available from the database to find the bottlenecks and the performance issue? So one of the objectives of this project is to reduce the need to manually monitor the cluster for most of the common problems faced. And also we want to provide the end user with a concrete set of recommendations on which they can take a concrete action. And I will talk about like some of the basic, some of the use cases which we have already implemented, and what are the recommendations really comes from them. So with that, I will kind of really move to the specific of like which are the recommendations which we have really implemented as of today. And towards the end, once after the presentation, I will also give a demo of most of these recommendations on a real cloud Yugabyte cloud cluster. And then we can talk about like what is the future and what are more things are really coming in this space. So so talking about the recommendations which we have implemented today. So one is the deletion of the unused indexes. So as we all know that index allows the database to retrieve the rows in a much faster than it will do without an index. Basically, it avoids the sequential scan of the whole table. Now, index can also impact the latency of the writes to the database. Basically, they can slow down the writes, as whenever you perform a write, one may require to write to the main table and as well as to the individual index. And this is a very common phenomenon across all the databases. So it is preferable to delete the unused indexes as they may help to improve the write performance. So we have implemented this feature to kind of collect the metrics from the database to figure out which indexes are not being used and show the recommendation to delete those unused indexes. The next recommendation which we implemented is the suggestion for hash versus range sharding.
So by the way, Sushant, I think one question on the previous thing, right? Like sure. Specifically, the reason why and delete unused index is actually more useful in a distributed SQL database compared to a traditional database. Like, can you talk about that? Is there like something there that matters, or like, because yeah, all databases have like your Oracle, SQL Server, DB2, Postgres, all of these guys, you could have unused indexes, but why specifically is this more important in the context of YugabyteDB?
Yeah, most definitely. So in case of a single node database, what happens is your writes are still going to your local disk. So the cost is much lower. But in case of a distributed database like YugabyteDB, when you issue a write, they may be going to a completely different nodes altogether. So basically, we incur an extra cost of a network RPCs for that. So the impact of the write latency will be higher in a distributed database than in a single node database. So that's where it becomes even more important to delete the unused indexes for a distributed database like YugabyteDB.
Got it. Because of the cross-node coordination, distributed transactions, etc., right?
Yeah. Yeah.
Okay. Got it. Okay. Makes sense. And yeah, this is probably an architectural thing, right? So it's just difficult to keep track because you may have created 4 indexes and then your queries will change because your application changes. And now you create 3 more indexes and 2 of the old indexes are useless. And it's better to have a automated system monitor this systematically rather than, go once in a while as a DBA and do this. And you might forget to do so and so on, right?
Yeah, exactly. Yeah, that we want to, show it automatically, so customer or the users can take action to clean up those indexes.
Got it. So Rajagopalan has a question, which is, does this recommendation include both the primary as well as secondary indexes, or what is the scope of the recommendation here?
Yeah, we do include both primary and the secondary indexes. Basically, the idea is if we are not using the primary key, then it's probably not the right primary key on that particular table, right? So basically, the recommendation would be to kind of change the primary key to the appropriate primary key, which is used in the query.
Makes sense. Awesome. All right. So let's keep going. And you are going to show a demo of a number of these things, so which is even awesome. But yeah, let's keep going.
Yeah, I'll show the demo towards the end of this. So the next is the hash versus range sharding. So YugabyteDB supports both hash and range sharding, and I put up a link for this. This has a lot of interesting information about how the hash and range sharding works in YugabyteDB and what are the various pros and cons for this. But in brief, with the hash sharding, the data is distributed randomly across different shards, which we refer to as tablets in YugabyteDB. So it kind of really helps you avoid any hot shard problems in the cluster. With range sharding, the advantage we get is that the data is kind of really ordered in a certain way. So the range queries, if a user is executing range queries, then it's preferable to have a range sharding, as it kind of really allows the data retrieval for that particular range to be much faster. Now, the default sharding type in YugabyteDB is hash. So for example, I have created a table employee, and the primary key is on the employee ID. So this employee table is actually going to be hash sharded on the employee ID. Sorry for the typo, but yeah, it's a hash sharded on the employee ID.
Yeah.
Similarly, I created another index on the joining date. And again, this joining date index is hash sharded in the same way, the primary key. So let's go to like, what are the most common queries customer may really run on this table? So one query customer may use is, let me get all the employees who joined in the month of January in 2020. That's what this query retrieves. So that get me the details of all the employees where the joining date is in the month of January. Now, this is a range-based query.
Yep.
And as much as we have a joining date index, an index on joining date already created, since that index is hash sharded, the query still has to do a sequential scan, that it needs to go to every shard and retrieve the data, and then filter out the results which are going to be part of this particular range, and then return those results. So what is preferable to, in this particular case, to have a range sharding for the joining date column. And this is an example of how to create a range sharding, that after the column joining date, the keyword you can append is ascending or descending to kind of define the order to create a range-based sharding. And after creating this index, if we run this select query again to get all the employee the details of the employee who joined in the month of January, then we will see that it is using an index scan, and the queries will be executing much faster as well. And also, I will also show that in practice in the demo, which is coming up right after this presentation.
Fantastic. Fantastic. And seems like a very practical thing to do. Yeah, makes sense.
So moving into the next set of the recommendation. So there are various ways to connect to the nodes in the YugabyteDB cluster. One could be using a load balancer in front of the cluster, which distributes the connections to different nodes in the cluster. One could be using our smart driver, which is Yugabyte cluster topology aware and can distribute the connections to different nodes. Or the external application can really manage these connections by themselves by connecting to each individual node in the cluster. Now, there could be now in this pipeline, there could be multiple issues may happen, which can really cause skew in the number of connections of the query process or the CPU utilization across different nodes. So for example, if we have a 3-node cluster, there could be a possibility that one node is processing higher number of queries or taking higher number of connections. than the other nodes in the cluster. And it could be due to a bug, or it could be just application not really using all the nodes in the cluster. So as a next set of the recommendation, we kind of implemented the auto detection of some of these common scenarios and really raise the recommendations for them.
Yeah, this is very fundamental, actually. This comes up quite a bit because, like relational database, traditional relational databases, right? You might have a, read replica or something, but those are not really a cluster. Those are optional. But in a distributed database, you always have a few other nodes, right? At least a couple of other nodes. So yeah, this makes a lot of sense. Yeah, very common scenario.
So just talking about the first one is the connection skew. So basically what we do is we measure the number of connections created against each node, and then detect that if any node is handling the higher number of connections than other nodes in the cluster on an average. And if a node is found to be handling like a majority of the connections, then of course we will see the performance degradation. So it's kind of one node is having more load, and there may be slowdown because of this, because there's just too much resource usage happening on that node, and that node may not have enough resources to handle on that. And the recommendation is to kind of really balance the connections evenly across nodes in the cluster. Like you might have to review the load balancer setting, or like the topology which is being passed in the smart driver, that if that is being correctly done. And if it is managed by the application itself, then just make sure that that application is using all the nodes in the cluster to initiate the connections to different nodes.
Awesome. Makes sense. Another one of those skews. Makes sense. Yeah.
Yeah. The second one is a little more tricky one, right? Sometimes the connections are easier to kind of really observe and see. The next one is harder. Like, what about if the number of queries which are happening on a specific node are much higher than on average what is happening on the other nodes? So for example, if I have a 3-node cluster, the node A is processing 10,000 queries per second versus node B and node C are only doing 2,000 nodes per query. And they could be doing it still with the same number of connections in each node. It's just that the connections on a specific node may be just executing more queries. And again, it kind of really results in the same symptom that we observe, the performance degradation, because as the high number of queries being processed, and the more resources are being used, which can actually may slow down the things, let's say, and maybe a bottleneck because of IO resources or the CPU resources and things like that. And then, so we auto detect this and kind of really surfaces, hey, this node is really processing like higher number of queries. And on the user side, what they need to do is like they need to review the connections and how each connections, how many queries they are processing, and kind of really rebalance those active or those connections which are actually going to be executing a larger share of queries across different nodes in the cluster, to kind of really to make them evenly balanced.
Fantastic. Yeah, this is a tricky one, as you said. Yeah.
And the next one is about the CPU. This is like one of the most common problems we see, right? Okay, I ran a particular query which was very CPU resource intensive, and that caused a higher CPU utilization on a specific node. So customer definitely want to really know about it, that, hey, there is a higher CPU utilization happening. The other aspect of this is also that sometimes the CPU utilization may not be as high always, but it's just much higher than the other nodes on an average in the cluster. So there are these two distinct points here, and we auto monitor both for both the scenarios, and kind of really raise a recommendation to kind of really indicate end customers or users to review why the CPU utilization may be higher. And another aspect of a distributed database is that even if we are connecting to node A, since we are a distributed system, that node A may be talking to all the different nodes in the cluster. So it's not always necessary that this is due to the connections to a specific node or the queries on a specific node. It may be just because of like, there may be an hot shot kind of issue where multiple queries are requesting all the same data, which is going to the same node and kind of causing a higher CPU utilization. So that's where we kind of really made it in its own separate category to kind of really indicate both the things that whenever there is a higher CPU utilization beyond a certain threshold, and also whenever there is a CPU utilization, which is higher than the average of other nodes in the cluster.
Makes sense. Yeah, makes sense. Awesome. So maybe we go to the demos.
Yeah, we go to the demos then. Give it let me maybe just reload it again. I think it timed out for sorry for the wait. It takes a couple of seconds from this screen to turn in a Cloud Shell sometimes.
But I really love Cloud Shell though. Even if it's so nifty, you don't need anything. You can just like straight up go and do your thing.
Oh yeah, absolutely. I actually started with enabling the access and everything and the connectivity. And then suddenly I realized I could just use Cloud Shell, and which just makes things much easier. I was worried about how do I will screen share multiple screens and things like that. But this is like, yeah, this is really awesome. So regarding the demo, I'll kind of first start off with the unused index recommendation. And I'll create a simple table. I named it as unused index test. It has two columns, H and R, and the primary key is a composite on both the columns, H and R. And I'll create another index solely on R as well. So basically now this table has two indexes. One is the primary key index and one is the secondary index. And since I kind of created the table just now, so those indexes are not being used. And I'll also insert a couple of rows in there just to kind of make the table complete in a way.
Could you turn on, okay, too late, you already did it, but could you turn on timing just so to see how long it took? But maybe that's fine.
Oh, okay. Sorry, yeah, I missed that part. Right. Okay. So I'll kind of really go back and say, go to the Performance Advisor tab under the performance sections for my cluster. And I'll hit the rescan button. You might see it as a scan button if you're doing it for the first time. I was doing it for the practice runs in the morning, so it was showing up as a rescan. So after it is done scanning, it kind of really shows that that it found the indexes in the database Yugabyte that they are never used. And if you look at it, it is showing both the indexes as not really used, and it kind of also reflects the create index command for those indexes. And the recommendation is to kind of delete these unused indexes. Now, let me go back to the shell and use one of the indexes, and let's see how that changes the recommendation. So I executed a query. I selected all the rows from this table. and I gave the specific h equal to 2 and r equal to 2, and that row was also existing. And I'm showing the explain analyze output of that, and you can clearly see from that that it did an index scan of that using the primary key indexes.
Yeah.
So let's go back to and hit the rescan button again. And now, since this index is already used, so it should not be shown in the unused index recommendation. And you can see we are only left with the other secondary index we created, and the primary key index has been removed from the list of unused indexes.
Yeah, makes sense. Yeah, makes total sense.
So similarly, I'll move on to the next one for a range and a hash sharding. So I'll create a simple table, the same table which I showed in the presentation, that I created an employee table which has employee ID, name, department, and the joining date, which is a timestamp kind of a column. And the primary key is on the employee ID. And I'll create a index on the joining date. Now, please note this, both primary key and the secondary index, they are hash sharded. So secondary index is hash sharded on the joining date. And I'll just quickly display the schema for completeness again, that the employee ID is hash sharded and the joining date is also hash sharded.
Yep.
So let's look at the explain plan of the query, which retrieves the details of the employees which joined in the month of January 2020. And as we can see, it's performing a sequential scan, even if we have an index on the joining date column. And the reason being, since it's a hash index, the data is randomly distributed across different shards. So so the database still has to kind of really get all the data from for the whole table and then do the filtering on the joining date. Now, let's drop this index and create an index as a range sharded. Basically, this ascending part is concluding that this is a range sharded index.
But did you want to show the performance thing, advisor, where it recommends change the index type, or?
Oh yeah, that is actually true. Sorry, I should have. I actually missed that part.
I got really into fixing this query. Who writes a query like this?
Right. Like it's too much core database in my head. Yeah, sorry. Thank you, Karthik. No worries. Appreciate it. I completely overlooked that. So, okay, I'll hit the rescan button again and see what recommendations are shown here. So the recommendation engine suggests that we have found the indexes which are using range sharding instead of the hash can be improved can improve the query speed.
Yeah.
So it lists out your index name, and it lists out the current sharding method. Basically, it lists out the create index command for that particular index, and it gives you the information of the table as well.
Yeah, fantastic. And I think the cool part that personally I like about this is, instead of just giving the recommendation, it also gives you the reason, right? Like, hey, timestamp column, it's better to do this, etc., etc. So that's fantastic.
Yeah, exactly. Yeah. So
yeah, I think we're getting close to time, Sushant. So maybe let's just go to the next one. Let's look at a few other scenarios. I think what you're saying is if we switch it, it will be a better plan, but that's okay. I think,
yeah, sounds good. So the next I wanted to kind of really show about the high CPU utilization and the connection skew. Now, in order to kind of really get those recommendations, the workload needs to run for some time. Like, we don't really raise these recommendations for a transient spikes. We do monitor them for like certain time period before we raise those recommendations. So I kind of really did this already on this particular cluster. So if you see here, then on this particular node, I just artificially ran the workload to kind of really have a higher CPU utilization than other nodes in the cluster. So that so this is about the CPU skew, where the CPU utilization was much higher on this particular N1 node than other nodes. So you clearly see that recommendation come out. Similarly, the number of connections which I actually initiated on these nodes were like much higher than the other nodes. Like other nodes were having only 1 or 2 connections, but the N1 node had like a 60 connections. So the performance advisor kind of really shows you the actual counts as well, and shows you like that the connections on this particular node were much higher. And similarly, for the CPU usage as well, it shows the CPU exceeded 80% for the 10-minute window when we ran the test. And it clearly identifies again the node on which really it happened. And the last one is like the query skew, that on this particular N2 node, we ran the workload only on this specific node and the insert workload. So it kind of really shows that this node was processing these percentage of more queries than the other nodes.
That's very cool. It breaks up the type of query also, which is super useful, right? Sometimes, one particular type could be imbalanced.
Yeah.
Fantastic. So one question from Rajagopalan, which is this: in the CPU high CPU, the CPU skew, if a node has a much higher traffic and if this results in high CPU, does the recommendation include some type of load balancing mechanisms for the cluster, etc.? So we mostly say rebalance, but the next level of detail, right? Like any thoughts on that?
So that's something we are still like exploring, because it's a little bit tricky to point out like one specific problem. So for example, it could be a hot shot problem. It could be just that the query layer is really taking too much, or too many rows are being processed. So we are kind of really we have plans to kind of really go more granular in that space to kind of really build more specific recommendations for the various use cases or reasons which can really cause the higher CPU spike. So that will be on the roadmap for the phase 2 and hopefully come up in coming months.
Fantastic. Awesome. This is great. What are the plans, upcoming plans? Like, where is this, is this it? What's coming? How are you thinking about it? I think people would all like to know.
Yeah, most definitely. So one of the most, couple of interesting things from a database perspective we want to build is the index advisor. So we made the recommendation that we should delete these unused indexes, but one of the common problems is, hey, what indexes we should really add in the cluster or in the database to kind of improve the performance of the queries. Absolutely. So we have the plans for that. The second interesting one is, in databases, especially in Yugabyte database, generally, most of the time we might do a distributed transaction, but then in certain, for the simple inserts or updates, point inserts and updates, we do a single row transaction, which is much faster as it avoids a distributed transaction. Yeah. So we are also going to be identifying the opportunities for the optimization in the query where we can convert these distributed transactions to single row transactions, which can really help provide like better performance. And the third category is like we are building more and more recommendations, like for hot shot detections, for out of memory going, or the temp file being used, and just a plethora of such activities to kind of really anything which we think manually an operator might ever do, we want to kind of really automate and just really tell them upfront about it. So these are like the 3 separate categories we are still planning to work on or continue to build for the future.
Awesome. Fantastic. And Piet put a comment in there, which is finding an anomaly like high CPU or unexpected ratio may not necessarily pinpoint the problem, because you needed to be able to, relate with the wait time and what is happening inside, right? And which is why the recommendations we expect, as Sushant was saying, will get better over time. But the idea is to expose something potentially that could indicate a problem, but may not necessarily be a problem, because the end user and the application knows best, right? Like what's going on. So, okay, fantastic. I think we are actually 10 minutes over, but this was a fantastic session. I really enjoyed it. If you folks have more questions, once again, please feel free to join our Slack channel, YFTT, the YFTT channel on yugabyte.com/Slack. And we will, get back. Sushant will get back and also continue to post comments here on LinkedIn as well. We'll monitor those. Thank you, everybody. Really, thanks a whole lot. And once again, feel free to join us next week, same place, same time, for another session of YFTT. Thank you, folks.
Thank you, everyone.